Good morning, good afternoon, good evening. Welcome to the CADclass podcast. I'm Josh.
Dude, that was way too quick. I'm Jake. Hey, everyone.
We are all jazzed on the energy of the most exciting theme song ever coming into this pod. But Jake, we got a full docket.
Every single week. For you guys at home, every single week, I'm sure you guys only see the countdown screen. In our bottom corner, both of our mics are muted. And so I just see little Josh in the corner of my screen just
dancing, baby. We're gonna have to up that game. But good morning, printed by John. It's really nice to have you. Cornelia, Connie, Ogre, Ken R. Good morning. Derry. Really nice to have you, Derry. Derry, good news. I have the drone materials to make the drone. Oh. They have arrived. So I'm very much looking forward to making the drone in chapter 3 of our book and printing some of those frames and starting to play around with that. I need a couple of recommendations from you, Derry, right off the top. I need to figure out an inexpensive controller. I don't care all that much that it's good. So if you could recommend an inexpensive controller and a charger for the battery and any other components I may need outside of that kit I bought, I'm going to assemble all of that and probably put that information in the Google Drive for folks that actually do want to build the drone. So drone build instructions.
Can I just say something very off the rails very quickly?
Oh, can you?
Right. Yeah.
Not only can you, but you should.
So I don't consider myself a hoarder of makers. I know a lot of them do. When I was doing woodworking every single day, I used to hoard those little tiny scraps of wood to use them as like stop blocks and stuff. I totally understand that hoardingness of the woodworking world and throwing stuff away. I get it from the machinist and metalworking side, keeping onto those tiny little things you could never safely work on and throwing those away. I get all that. That's fine. But with electronics, I find myself hoarding old tech's components with no knowledge of how it works. So I have like I had an external battery, a phone charger thing, and I dropped it, and the screen read something like 513 or something, apparently, which is like a standard error code that's like, it's broken, it doesn't work. And so I cracked it open, and now I've got like a massive, chunky, like phone-sized LiPo battery. I've obviously like moved the terminals well away from each other and grounded it, but it's a huge LiPo battery. And I just have it in my drawer, and I'm like, oh yeah, when I make some big electronics projects, that I'll need it. Yeah, sure. And it's only just crossed my mind now that I have no idea how to discharge it or how to charge it safely. I have no clue. It's just been sitting in my drawer.
That's hilarious. Grandpa Makes is Ken, by the way. So Ken, it's really nice to have you. Grandpa Makes, you are one of the posters in our Discord that has been making amazing stuff.
Yes.
Amazing. One among many, and it's growing. So Derry's going to do a little bit of research on the drone and just see what's out there these days. Are you going to try goggles too? Go ahead and Derry, if you wouldn't mind, just give us the whole list, and then I'll break it down into necessary and optional. And that way, people who build this project, if they want to make this thing at home, they'll know exactly what to get, where to get it. It's taken me a little bit of time to do that research. Actually, Derry, a little bit of time to do that research. So yeah, that'd be amazing. And Jake, how about we frame some of today? So we're going to talk today. We're going to start with the challenge from last week. So for those of you who don't know, we had a challenge, this 3-dimensional object that it turns out wasn't that obvious or easy to make, and it's not clear why. So we're going to talk. We were working on it. I say we as if I did anything. I sat here commenting, but we were working on it last week, and then we challenged our community to build it, and we had people build it in Fusion, and we had one person build it in Tinkercad, which is absolutely
very
outrageous. Then we're going to talk through some of the amazing stuff that you all have made, and we have a couple files to show off. You may have seen it if you're in the Discord. I'm just going to tease it and leave it right there. We're going to talk a little bit about Autodesk Fusion certification for those of you who are trying to prove your skills or need to do something like that. We've done some research and understand that. And then Jake, you are going to finish it off with a challenge. Did I hit all of the main points?
Basically, yeah. But everything except for one thing. So last week we had a little Reddit campaign. If you're a Redditor, you may have seen some me holding my book, or our new book, and just kind of posting it on some 3D printing forums, Fusion forums. all that good stuff. So I think we'll probably have a couple new people, but to everyone new from Reddit, hi, very, very glad to have
Welcome.
you.
It's really nice to have you. We
Getting the
got a
book,
big boost from
downloading it.
Reddit. Once again, we posted it, and half of the Reddits got taken down for advertising promotion purposes. Whatever.
Which I get.
We
it.
Reddit has basically loved us, except in some cases where they're like, no, this is self promotion, and fair enough. We're not trying to violate those rules, but I want to say big thank you to those of you in our community who comment and post and give feedback to people in those forums, saying that you found it useful. Just general internet good vibes coming our way. I think Jake and I felt increasingly grateful for all of you, and I love seeing the comments come in there. So thank you all of you.
I did see a couple comments from people that I know are on the Discord, just singing songs of praise, which just warms my heart, and incredibly thankful. Thank you guys so much for all the nice words, for basically just saying,
these guys don't suck.
I've gone through their programs. Their projects are really fun. I learned lots. I was able to make my own projects. I've got certified. I started a project. I started a business. It was all really, really lovely. And I'm just really thankful. So thank you very much to everyone.
Little gratitude to start the pod. Okay, Jake. Challenge last week. Can you frame what was... So as you pull this up and show people that are actually watching instead of just listening, can you frame to us what exactly is challenging about it? And then we'll talk through some of the solutions that people have found, and hopefully that increases your ability to design things on your own, which is ultimately our goal, that you guys design more amazing stuff.
So I'm going to drop a little bit of philosophy on you, because we haven't done that in a little while, but I'm going to drop some maker philosophy. And there's this very old engineering-y adage. I think it's more philosophical, but I think it makes sense to the engineering or the maker. And that complexity is not the hallmark of design. Simplicity is the hallmark of the design. A really good example is just like a pendulum clock. It's actually very, very simple, but it took an absurd amount of work and effort and mathematics and material engineering for literally thousands of years to figure it out. Where on the other hand, if I smash a pint glass onto the ground, it'll explode into a billion pieces that are infinitely complex and would take a billion years to put back together again. So you could argue that is complex, but it doesn't really take much effort to do it. And so anytime that I see a design that is very, very... that works and is very, very complicated, it's like, yeah, okay, that took a lot of work to do. But when I see another design that solves that same problem in a really, really beautifully simple way, it looks like less effort, but I know that it is so much more in depth, and it's so much more creative, and so much better through and through, and it feels good as well. So with this,
I have an analogy in writing, and this applies to us writing the book as well, is there is the illusion that a simple text was easy to write. And the same argument actually applies. And that is, how much time did it take us to whittle down sentences and clarify projects and continue to streamline, right? Fewer words on the page is not our goal, but saying things simply and cleanly and getting to the point and removing unnecessary information it's extremely challenging and taxing. So sorry, keep going. I'm liking this philosophy quite a bit.
So the project last week was, I would like to call it a menagerie, because I don't get to use that word very often. It was essentially a cube that had the letters X, Y, and Z on all 6 sides, and it was projected through. And basically, where the negative places of the letters on the 2 edges joined, there was a cavity that was removed from it in really clever ways. And it sounds very, very simple. And as you look at the design more and more and more, it becomes more and more, oh my God, okay, I can kind of figure that out. Oh my God, that one's a nightmare. And it just becomes this massive, massive, massive dwell where it looks very, very simple, and it's a nightmare to solve. I tried to do it live on the podcast with a couple days of just hearing their thoughts, trying to figure it out, going, yeah, I know what I'm doing. I totally didn't. Failed under the clock. But we got some people that really seriously blew me away for how cleverly they figured it out. There we go.
We can add an extra LY. That's fine.
That's fine.
Yeah.
So we wanted to show those off on our Discord because, dude, I I think I saw 2 people that solved it in Fusion, 1 person that solved it in Tinkercad, which is amazing on its own. But I just wanted to highlight the Fusion people because I want you guys to send me those files, please. I want to take a look at them. So we got ZDP that made it in Tinkercad, which is insane. That's crazy, dude. That's amazing.
It's really
you're able to do that.
I mean, I think not that we're recommending people use one tool or another, but the point here is you can, Jake, you and I say this all the time. Start somewhere and get good with CAD. Even if that means Tinkercad and getting really good at it, don't get stuck on it for too long, unless of course you're ZDP and that's what you enjoy, and that's kind of the design that you're really loving. Then by all means do it. But the point here is you can get really good at these tools, even the ones that are built from just adding, subtracting primitive shapes, as pointed out here by a really difficult challenge in Fusion that ZDP pulled off in Tinkercad. So well done.
Amazing.
Bravo.
As expected, Connie did fantastic on it. It said bottom part was crazy hard, drove me mad. Feel like I'm missing something. Yeah, this is an intense project that just looks so simple. Again, this was I believe originally posted on the Fusion 360 subreddit, which is actually hit or miss with some content. But Ed Charlwood, who wrote our Tinkercad book, sent it to us and said, "I'm pulling my hair out. I can't figure this out." And he's been doing CAD just as long as I have. So yeah. And then Connie figured it out as always. We're gonna skip over that. And then Derry figured it out as well, dude. Fantastic.
And Derry says, LOL, mine's a mess.
That's fine. That's fine.
I just like the attempt, right? I just like the attempt.
I think it's amazing. Please, guys, send me the files because I want to show it off because that is amazing. But speaking of challenges, speaking of projects, at the very end of the book, the very last project to do, the full arc, is to recreate, a legally separated thing that looks a little bit and is honoring the heritage of Luke's lightsaber from Return of the Jedi. It was the first thing that I ever made. I still have it. It's one of my most favorite things of all time, and I loved making it and learning about it. And the last challenge in the book is to essentially recreate some project, some prop from a movie that you love, because it's a really big hallmark that Josh and I have always kind of stuck beside, that if you are learning a new tool, whether that is software or a physical actual machine, going online and seeing simple projects, fun projects, it is usually going to give you garbage. It's usually going to give you really awful, crappy, boring projects that you don't care about. But making a project that you are in love with, that you really want, that you desire, even if it is unbelievably complicated, like a lightsaber from scratch when you have zero experience, it pushes you and pushes you and pushes you to learn even more. And it is just, it's the best way to learn. It sounds hard and it is intimidating, and I'm not saying it's not, but it is the best way by a country mile. So Connie, over the week, before I hand on the challenge, spent the last day finishing the last challenge from the book, Making a Lightsaber. Dude, look at this. Like, I can't believe Connie made this.
Connie, it's
very, very, very fitting. And for you guys that don't know, the voice of Darth Vader, James Earl Jones, just passed away yesterday. Very, very sad. But dude, this is just so unbelievably good.
And by the way, I like to frame this. We probably say this every week for the people that are new and new-ish, looking at some of these projects and going, "Wow, this is absolutely incredible." Connie came into this, I believe, took the video course and then has gone alongside the book as well, and basically came in and started from scratch.
Mm-hmm.
So, and it's been maybe 6 months to a year. I keep kind of butchering these numbers just a little bit, but it's somewhere in that range of working consistently, building the projects, and actually attempting the challenges in the book. And this is where you end up when you do that. So, Connie, I love just showing off. Like, it's intimidating looking at your stuff because you think, how could I possibly do that as a beginner? But man, it's possible. You didn't start that long ago. If you can do it, everybody else can do it too. That's what Jake and I are trying to show off. So,
and I imagine
so she
when
says
Connie came on,
1 year. She's been doing this for one year,
yeah,
with some pauses in between.
Yeah.
So you can do it. If you're new, if you're just starting and you're intimidated by all this stuff, just keep going. You can do it.
And I imagine when Connie first started, she saw projects of this caliber, of this complexity, and went, "There's no way I will ever be able to figure that out," because everyone feels that way. And it's one of the like little hacks that I find with CAD, especially, or really with any project where things look incredibly complicated, incredibly difficult, and then you learn a little hack and it changes everything. And that is that although the assembly looks incredibly complicated, if you break it down into all of its components, it's actually shockingly simple. It only looks complicated because there's many parts to it. Like recreating a smartphone sounds incredibly difficult until you realize there's like bolts in it. And you're like, oh, okay, well, I can make a bolt. We did it in chapter 3. I can make a little countersunk bolt. It's just got an angle and it's got a special head on it and a thread. It's like, great, you've made one part. Now move on to the next one.
Can I double click on that philosophy? Yeah,
absolutely. Go ahead.
I want to dive especially deep into that. And I think this is, if I could summarize the entire strategy of learning CAD, and especially when you're, like you're saying, when you're going to build something that's complex, ask yourself, what's the simplest thing on this design that I can make right now? And if it's still too complex, break it down even further. So I'm looking at a camera right now. And if you were just looking at this at a camera and going, I'm going to make this, it would probably break your brain. So I could design the lens, right? I can design one lens, or I can design a cap, or I can design a button, or I can design the front face, or I can make a block that sits out, or the fold out screen. Right? I can design one small piece of this. That's where I should start. And don't worry if it takes you a while to come back and, oh, I need to up my skills to be able to design this thing that's now slightly more complex. The simplest possible place to start is the spot you want to start.
Yeah.
Okay. Take it away from me.
We're full of philosophy. This feels back to form.
Yeah.
This feels really nice. Anyway.
Yeah.
So Connie sent me the file. She said she doesn't want to release it, which is perfectly fine. But I have it open on Fusion. As you imagine from Connie, it is a lovely file. It is very organized. It's wonderful. I have it. I literally just got it. Just uploaded it to Fusion. It's fantastic. I'm sure it's absolutely as organized and as
Connie. Now we want to see it IRL. We want to see it in real life. So that's your challenge. You got to make it.
I have a little tangent really quick that I think I think a lot of our audience are nerds. I think it's fine. In the world of prop building for movies, they are oftentimes not making things from scratch. They're just grabbing things that already exist and mashing them together, and then painting it and weathering it, and it looks amazing. So in the world of prop making, which I love, there is this really weird divide right at the very beginning of, okay, well, do you want to make it look weathered and ugly, or do you want it to look brand new? And that's it's personality traits. I always like to make things look shiny and brand new, but other people like to smash it up and stuff. Like for my R2D2 project, a lot of people will make the entire thing and then smash him with a ball peen hammer because he's got dents all over him.
No,
because of course he does, because he's a character in a space movie. I'm not doing it. I can't do it. He's going to be polished and lovely, and I'm going to buff his lovely domed head. Probably by the time I'm done, I'll probably have a domed head as well. But it is. But there's an also like slightly deeper subsect of prop making that is, I think, a little bit exhilarating, and that is finding all of the original crappy parts that actually made the real prop and joining it together. For example, give me one sec. This is my lightsaber. It's made out of solid aluminum. It's like 3 pounds. The very end of it, if I can cover my face, the very end of it is called the pommel. That's a little spiky thing at the very end. It was made out of a faucet knob on a sink. That's what it was originally made of. And so a lot of people that are super deep into this nerdiness, they will track down all of those individual components, like all this stripy business in the middle. That was the solar cell of a very, very old 1970s calculator. And so people will hunt this down, all these pieces, and then assemble it. And in real life, it looks like junk. It looks like actual garbage that a child would make. And then you look at the one that was pristinely made out of metal and hard work and tears and sweat, and you just look at them and you go, there's no way this is actually how it was, and it's totally true. And it's really, really funky. And so, yeah, I love that kind of stuff.
I think that hits on something kind of important too. And Connie says, damaged gives you more story.
True.
And well, I'm not saying there's plenty of story for all of these things, right? But I think what's interesting about that comment is story is a fundamental part of making. We forget sometimes. There's stories behind the objects we use. There are stories behind the people that made them. There are stories. The story is interesting. The journey is interesting. Bit of philosophy once again, right? It's like, don't lose sight. We're not simply making things to make them and pump out more. We're not thing makers. We're doing this for a reason. We're doing this to help somebody. We're doing this to satisfy curiosity. There's a story behind it. So I love that frame, Connie.
This when I was making my lightsaber, but the general manager saw me making this and said, "I know what that is. You're making a lightsaber." And I went, "Yeah." I found all the dimensions online through a sketchy website, and they're all accurate. And so I'm trying to recreate it. It's taking me forever. And then they essentially said, "Oh," and then he was touring around some kids. Said, "Oh my god, you're making a lightsaber? I want to make one. And then said, "Oh, do you want a job?" And then I started teaching kids programs. Then I started teaching adult classes. And then I started learning in much more depth all these tools. And then Josh and I left that facility. So this lightsaber, as crappy as it is, it's rough in a lot of different areas. It's a really weird fundamental part of my life. And so I love it for many, many reasons. But I like that idea. We are making stories.
We're making stories.
Wonderful. Okay. I want to dive into Connie's file very, very quickly, just to show off just how much detail she put into it, because it's wonderful. I can already tell it's lovely. So let's dive into Fusion. Just want to see her file. It is magnificent. It is so.
Can you talk me through too, for the viewers and listeners here? Can you talk us through what you think about organization and structures? Mm-hmm. This is a great project, because I think a lot of people come in here and they go, do I just design stuff? Like, how do I save it? Does it go inside of a new component? How do you decide what a component is and what it is not? So can you use this as an opportunity to talk to some of our people through that?
So it's often easier to find the story of logic by starting at the very beginning and working forwards.
Okay.
But it's always easier to find out what type of maker they are by going in the opposite direction, which is very, very strange. But if you look at the timeline, every single component is in its own group. And all of them are named as well, which is lovely. This implies to me that someone is wanting to go back to this file. Oh, I made it just for fun, but I may want to actually make it in real life. So I need to have some type of memory that goes along with it so I can track all the pieces. Or I may want to give it over to a friend so they can make it. So all of the parts that are actually named is really, really, really integral. If we go back even further and actually expand all of these groups, you can see some of them are very, 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 very simple, like this blade, where it's essentially just a revolved sketch. But then all the joints are inside instead of externally, which means that you are more focusing on making a simple timeline, which is lovely. But all of the components look nice and simple, but I'm just going to work my way back step by step, because I need to figure out the brain of Connie. Okay, so for everyone that's seeing it, we're all noticing something, and that it started at the back and works their way to the front, which is a really good methodology. If you are confident in your skill set, literally physically working from one side to the other of a project is oftentimes a lot easier. It's making your life a lot easier in the future for any type of construction where you don't need to rejoin things, you don't need to make things in external files, then bring them in, which can be a bit of a pain. It is all just in place organically, really, which means you don't have any files that need to capture positions or undo capturing positions, which is a headache on its own. if you make everything in place, that is incredibly, or is much, much, much easier to do. So this looks like the back end cap. So it looks like a revolved pieces, but all these knurls on the outside. Do you see how every single knurl has an embedded internal fillet on it? It's actually a cut-in knurl. That's taking a lot of rendering power. I can actually see my mouse lag as I move it. So this is one of those aspects where if this was made with a straight knurl on a machine, I don't need to put in an absurd amount of detail, because it's not something like nobody's going to actually go in there and route all of these individual fillets. This is just something that happens naturally with the tool. It's especially like if you are going to be machining something or putting something on a lathe. Normally, a lathe tool has a radius on the very end of its cutter, and so any internal corners you can model it sharp, and then in an engineering drawing reference, just use the radius of the tool, or just use this special tool insert to provide that radius. You don't need to model everything in it if you know it's naturally going to come from the manufacturer. Similarly, with this thread as well, this could have been left as a decal if you wanted to, but I think Connie wanted to, in the exploded diagram, actually show that part rotating. And that effect doesn't really come along if you just do a decal. So this project, if I was going to give it over to a manufacturer, yeah, you can do it, but it's probably not necessary. This really large chamfer, I'm very, very interested by. But this back section, that all looks good. All looks very nice and neat and efficient. Fantastic. Next bit is the handle. These handles were made from I think 1930 Graflex flash bulb. If you were taking a camera, you'd have that exploding bulb, and the handles are what lightsabers are made out of. And a lot of classic photography nerds are very pissed off at Star Wars nerds, because you literally need to buy this antique. There's only that many left in the world,
and they've made it so expensive.
Sawn it in half. So a lot of camera people buy them at absurd prices, just so Star Wars people don't cut it in half, which I get. I totally understand. But it does mean if you are recreating your own lightsaber in real life, you have to ask yourself, do you write the text Graflex on the handle? Is it a part of Star Wars, or is it just a part of the physical prop? Who knows? But this is lovely. Everything is looking nice and neat on that. I don't even need to look into the timeline. I can tell this is patterns all around. It's dovetail pattern. Fantastic. That's going to just slide in all of the rubber piece on the outside. All of these pieces, which I believe are car windscreen wipers. The rubber bits. That's what all of these are. The grips on Darth Vader's handle. That's what they're from. I'm pretty sure that's what they're from. But that's lovely. Those just slot into place. Again, all this, all the original parts, they were just made from old calculators, which are just lovely. And then all the little holding. This part where it grabs onto this is one of those pieces that I've never figured out how to make on like a mill. I understand how to make it with sheet metal bricks, which I don't have. But these are all these lovely parts. These are made very, very nicely. Nice and neat. I wouldn't be surprised if this has been made with the sketching. Yep. Is it this piece? Yes, it is. So this piece, if you were going to design it to be made, you may want to consider making this as a sheet metal part, because this actually has to be molded around a form, essentially. So even though it obviously does make sense here to make it in the design workspace, if I was going to be making it in real life, I'd probably do it in the sheet metal tab, which looks complicated.
Unless, very simple. Unless, of course, you just wanted to 3D print it. And then,
so,
but point here being designers is what we're starting to blend is the idea of CAD modeling as a means to make something. It's not always what you have to do, but if that's what you're after, then you start to need to integrate the idea of tools, materials, access, availability. What are the capabilities of these things?
100%.
What can I actually do with it? So I love the extra context.
Lovely. Is this a USB-C port? I don't know.
Yeah,
I don't know if that's real.
Like that's amazing.
If that's real.
Is it on the inside? Is it poked all the way through?
No.
Oh, okay, that's awesome.
I don't know if that's real or not, or if Connie was or if she already had one of these lightsaber props and she was measuring off of it. If so, that's hilarious. Yeah, this all looks absolutely lovely. Continuing on, all of these little details, you'd be shocked at how adding tiny little details like all these wires on a part, how much more realistic it makes the final product feel. Especially if I was going to be handing this over to a client, adding these little colors onto it transforms a project. Like seeing all these little LEDs light up in the renderings, that makes a project. Seeing the reflection on all the metallic parts, it takes a little bit extra work. That's why we split up our later chapters into appearance and rendering. That's why it's so incredibly important. But going on more and more and more, this is just such a wonderful file. Connie, hats off. This is fantastic. I cannot wait. I hope you make this in real life. I hope you build up some skill set on the
I'd be shocked. I'd be shocked if something like it isn't made.
Yeah,
Connie, you seem like you'll make it.
Gosh, this is fantastic. All right, I love that. That was fantastic. Where are we? There we go.
So Jake, each of those. So can we talk structure-wise? So each of those were components, and then inside of the components there may be sub-assemblies. Can you talk us through the structure of the thinking around when to create a new component, when not to create a new component, when it's an assembly, sub-assembly in a project like that? You're starting with the end cap. How are you conceptualizing of the organization at a high level?
So anytime I'm working on a project, I kind of need to split it up into the assembly is the entire thing. And for a lightsaber like this, it's all one thing. And I use the word thing very, very vaguely on purpose. There's no splitting this up. You can say, oh, that's the front half and that's the back half, but there's no actual real divider, really. I think in the book we split the top section because there's so many small components and this part juts out from it. This is the block assembly or the block sub-assembly. But as far as that lightsaber, there's not really that many discerning differences or different halves or front or inside or outside. It's all just parts for one thing. And so making it as just an assembly made of components makes all the sense in the world. But if I was going to be making different projects that has like a car that has very definite differences, it's got the engine, the bodywork, the wheels, there's much more obvious categorizations of it, then that's where I'd kind of jump into sub-assemblies. But all of those sub-assemblies, there's no rule book to say what's right, what's wrong. It's just kind of feel. It's just kind of organization. One thing that you can do is that when you group things into assemblies and sub-assemblies, and we did this with the newest version of the Tesla turbine. If you haven't gotten to that, it's much better and much more fun. We've actually divvied it up into the housing and outlets, and then, or the stator, all the things that are stationary, and then the rotor, all the discs and spaces, the things that actually rotate the rotor. And so when you're designing this, you can actually hide all of the stator components, or you can hide all of the rotating components. And so it's very, very easy to say, oh, I'm just working on this portion, or I'm just working on this portion. So it makes like a lot easier when you consider, if I was to hide a grouping of parts to make designing the inside pieces a little bit easier, what would I do? Would that make life any easier? And for the lightsaber, probably not, because it's all linear. Like nothing's hiding anything else. So in that case, I don't think it needs to be any more complex. I think Connie nailed it as far as the design and the architecture. But to get to the architecture stage, you need to have some experience in CAD. Like you can't just know how to set up all these kind of high level organizations. You just kind of have to put the work in and you'll figure out the logic pretty quickly.
Moral of the story, something we talk a lot about. Do it a lot, make a lot of things, make some mistakes, and ask yourself these questions as you go. Did I organize this project in the way that makes the most sense? Was I able to access inner components while, right? Your stator rotor example is a good one. Was I able to access and see the parts that I needed to build? When I tried to give this to somebody else, do they understand the logic? This is something that happens in computer programming a lot. It's called commenting, right? So in your code, you're going to comment on what it is and what the purpose of it is. And the cleaner that commenting and the cleaner the description of the code, the more likely it is that another human being is going to be able to understand the logic of what you've done. And so asking yourself, am I going to need to communicate this design or the design intent or this project to somebody else at some point, or even to myself in 2 years?
Yes,
right?
which
You
is
forget what you did.
so much more important than people recognize.
You're like, you're not going to remember how you thought about going about this if it's not cleanly organized in a way that makes sense. So these things go together. It's not like you learn
Especially if
organization.
your skill set improves.
Exactly.
It's not just like, oh, I forgot the logic. It's like, no, you've progressed, you've graduated, you've gone into the beyond. Yeah,
but these things are together, right? These are not separate skill sets. You learn to organize things as you design more things. So keep designing things and keep asking yourself, did I design that in the best possible way? And the answer is going to be personalized to you in a lot of cases. Or if you're working for an organization, they may have a structure they want you to follow already. They may have rules of thumb. They may have some, and so it varies. But do it together. Do it by make more stuff. Is still the moral of the story. Make more stuff. Keep designing in CAD.
I totally agree, man. I totally agree. Yeah. Finally, Connie, that was fantastic. That was lovely. We want to move over to a new topic that we've been working on behind the scenes for a little while. We saw a couple of comments on Reddit from our posts with people saying, I took your course, thank you very much, lovely. But then they went on to take the Autodesk certification program. Josh, can you talk a little bit more about that?
Yeah, so it's called the Autodesk Certified Associate in CAD for Mechanical Design. So we've had schools and teachers specifically start to ask us about these certifications and how they take them, how they pass them. And so now because we've had 2 people, like you said, go through our course and then go in and actually take the CAD for Mechanical Design certification exam and pass it, I figured we'd take a second to talk about it, how you might take it and how you might pass it. And so it's one thing that people don't know is now you don't actually have to go to a testing center to do it. You can do it at home. There's very specific requirements for taking the test. Like you have to have your camera on and you have to show the test person where you're taking it. And there's a whole series of things, right? But more importantly, if this is something that you need to prove that you've done, if you need to prove to your workplace that you've actually learned the skill, or if you're a teacher, a lot of times with teachers, the districts and the schools themselves will get extra money for students that actually pass these exams. So we figured we'd take a second to tell you what is involved with the exam, roughly what it's like, and how we cover it in our class. So
I think I want to expand on that really quick. It's not just teachers, it's also people that can get promotions, people that can get jobs and actually have proof, like we've had people in the past where they do have, or they work at a facility. One of our beta testers works as an engineer, and then they got an even higher position because not only did they complete our program and got our certification, but they also then proceeded to get a certification from that software company. Yeah. And so it is really a two-handed driving force for a lot of people, both for students, both for teachers, both for professionals. Yeah,
sound like me.
So it's really wonderful. So if you do want to get a certification, or if you have gone through that process, we're currently in the process of doing some work behind the scenes to make that a little bit easier for our community. But if you have gone through the certification program recently or in the past, do reach out to us. You can message us on Discord. We want to know all of your feelings on it, how you went to it, and just as much info about it as you'd like to give us, really.
And for those interested in it, I'm just going to talk high level, what you actually need to know, and then I'm going to map that onto our curriculum. Because Jake, the funny thing here is we didn't design our curriculum to be aligned with any special exams. And actually, I think that's the beauty of it. Had we gone and tried to work backwards and say, well, how can we teach the skills necessary for this exam? I think what we would have created would be boring. So the idea for us was, let's just make fun projects that we're interested in making. And our main hypothesis was get really good at making models by making a lot of models, and then the rest will follow. So basic ideas that are covered in this exam. You need to know how to create and modify sketches. You know how to do that after the very first project in week 1. We do that in every single project throughout the entire thing. I don't need to get any more details there. You need to know how to create construction planes and axes. Create and modify 3D solid features. We did. I mean, This stuff is
that's the entire book. That is so.
It's every single project in our entire book. You will learn those things if you just work through a couple of projects. Inspect and analyze models. So using the measure and inspect tools, and then using section analysis. We do the measure tools in the week 3 drone project. We do the section analysis in week 2 geocache. The direct modeling features. So press pull is one thing that we don't talk about. We have mentioned press pull a little bit on this. So we don't directly cover press pull, but
we will be adding it to the next edition. It's already logged.
Yeah, so we'll add press pull to the next edition, and we'll show you some instances where you may choose press pull over extrude, but just know that it's a similar.
We have a YouTube short about it. You can look it up if you want.
Totally. The one thing we didn't also cover was the freeform parts, primitive box, primitive sphere, right? So, but really easy to poke around with just creating a primitive box and a primitive sphere. You just pull those 3-dimensional objects in.
And these are pretty basic topics that we're going to be covering in our Fusion Fundamentals book as well.
Yep.
That's coming out.
Creating and organizing assembly components, week 4 assemblies. You could just do one project there. Creating motion, right? Motion animation. Creating and managing motion links, motion animation. Apply assemble interference tool. So using the interference tool, we do that in assemblies. We do that on the phone case.
So we basically,
last but not least, and then we can move on, are engineering drawings. So if you did one of the engineering drawing projects, you'd have everything you need and way, 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 way more to pass this exam. The exam is 44 to 55 questions, multiple choice. You're not actually in the software. You are just answering questions based on either what you see, or there's a couple of like live questions where they pull a piece of the software in and you can interact with a small bit of the software. But the idea here is that or not the idea, but you can pass this test with flying colors and go far beyond the knowledge of it, taking our course or going through the book. You don't even have to pay for anything out of pocket. You can go through those chapters in the book that we've mapped to that exam, and you're golden. You'll pass it. Yeah.
He's busy.
Yep.
In that vein, one of the things that we're planning on doing with this certification program is kind of leaning into another part of CAD testing that comes up pretty often. So in the university education side of CAD, there is a pretty standard type of test or type of final. We've talked about it in the past, where you're essentially given a piece of paper where it's got a top, right, and front view, maybe an isometric model, or maybe an isometric view, and a bunch of dimensions on it. And you have an hour, maybe less, to recreate that file in your CAD program of choosing. And you need to produce, or you essentially say, I've added this default steel material, and then you write down the final weight of it to the hundredth of a gram. And if that value is the same as the teacher's value, then you made it. But you may not have passed that exam. You also need to have made this project in under 10 features or so. So not only do you need to make the problem correctly, but you need to make it accurately and efficiently, which is the step above. That's what I think that's where, personally, I believe that's the difference between a CAD technician and a CAD engineer, where they understand the logic of 3D modeling and 3D space so well that they know in which operations can they group things, can they do things at the same time, nearing the beginning, nearing the end, which will save time. Because if you're working on a project that only takes 10 features, it's not that complicated of a thing. But if you're working on a project that requires 1,000 steps, which I've absolutely worked on, but you've got a friend that can do it in 600 steps, they're going to get the job before you every single time. They're so much more efficient. And so in that vein, we wanted to make a very simple project. So I just went onto Google and I just found a pretty basic CAD example. There's millions of them, and they're really good practice. But what is never taught, and I don't know why, is the logic or the mindset of how you should be thinking of creating this as you go. And it really comes down to a handful of things that you need to learn, and it changes how you view 3D objects. And this then goes into how you recreate stuff in real life. These very basic, weird objects, they're meant to be strange on purpose. They don't represent anything in real life. Like maybe you'll have like an interesting flange that you're like, yeah, I could see that in real life. Most of them, they're just kind of funky blocks with ribs and holes and threads and all kinds of weird stuff on purpose. It's not meant to be realistic. And so I think we're planning on doing a little bit of the random stuff, but also the real stuff. How would you recreate it in real life? So without further ado, let's go ahead and get started because it's a pretty simple one.
And Jake, for the folks who want to work alongside of you, can we get the file up on Discord? Or the link? Just share the link on Discord. I would love for those of you who are down to go ahead and try to recreate this.
Yeah.
And this will be the week's challenge. Yep, this will be the week's challenge. We're going to try to keep up with this idea of these little designy challenges. And then we'll talk through the logic and the structure and hopefully come back and you all learn with us.
Lovely. All right.
Or teach us in a lot of cases as well.
Yeah. Oh, absolutely.
Let's not get arrogant over here.
Okay. So this is just, I think it's like the first picture on Google. I literally just grabbed it out of a hat. But you've got an isometric view of the project, and then you've got your top, front, and right view of the model. Anytime you have got solid lines, that is a harsh edge. Anytime you've seen dotted lines, that is a hidden edge, you'd call it. Essentially, if you imagine this hole that's in the middle, you've got this edge and that edge that are obviously vertical. Those are translucent. Those are behind the scenes. Sometimes in tests, you don't even get those. You only get the visible edges, which is a little cruel. But as I'm looking at this, we're going to be going through this and recreating it from scratch. If you guys want to open up Fusion and work along with us, go for it. But we're going to be going through some of the things that I look for, and it's going to be a little bit of a challenge for people who've never done anything like this. But let's get started. So the first thing that I notice when I take a look at this is I see two angled walls that I'm just going to assume are coplanar, essentially. Then I see a hole in the middle, and then this kind of square with a corner taken off prism, and a flat wall on the underside. So the first thing that I like to do is either work subtractively or additively. And it's essentially personal preference. If you have making experience and you are a woodworker, then I approach projects usually subtractively. I start off with a big block of wood and I'm removing material. I'm cutting out holes, carving away, cutting until I have the final project. If you are a maker, but you only have experience with 3D printing, then you may physically look at this and think, oh, this is all additively. I need to extrude that, extrude that. Now I look at this hole and I go, oh, that's something that I need to cut away. Some people may look at this and think, oh no, that's a bottom platform, except for the circle that I'm extruding upwards. There's different methodologies. One way is going to be a little bit faster, but we'll get into that in a little bit. But the other thing that I'm looking at is what features in this can I remove because it's only a single step, or that I can simplify this model a little bit faster. And the first thing that's coming to my mind is the circle. This doesn't really share any other geometries with anything else. Like this cutout right here on this side, this shares the same angled wall as this wall over here. And so this circle is just kind of blurring my view a little bit. So if I just imagine if I remove it, it becomes a little bit more blocky and a little bit more geometric. The other thing that I'm noticing is because I think subtractively, I see this kind of blank volume in the middle. And my first thought is to take this right side profile and just extrude it outwards, this 50 millimeters, into a solid block that's essentially got a chamfered face on it. That's the first thing that's coming to my mind, and then removing this material because I've got a top-down view. And you can kind of see if I trace my cursor around it, I've kind of got this rectangle with its corner square taken out that I could then extrude cut from the top down up to this layer, which would be 7 millimeters or 7 inches from the top. And then I could have access to that flat surface, and then I could extrude cut it. Now, there's other people that would say, oh no, I'm kind of noticing that these two angled walls on either side, they're the same thickness, they're 7 millimeters wide. So I could start off with a flat surface, that 50 by 28 millimeters block that has the hole already cut out of it, and then make one wall and mirror it to the other side. And then I just have to extrude this little tiny corner there as well, and then I'm done. And all of these different logic paths will get you to the same final goal, but which way is faster is the trick. And I'm going to go with subtractive route, and we may have time to make it additively. I have no idea which one is going to be faster. I'm just going off instinct. And the only way I know this is because I've done about 1 billion of these. So I'm going to be going back and forth between Fusion and this page. But let's get going. Again, if you have Fusion open, go ahead and model this at the same time. One of the rules of these drawings, which is very, very important, is they will never dimension the same thing twice. If you have the width, or I suppose the length of this part, it is denoted as 50 millimeters in the top-down view, but it isn't denoted in the width there. So if you hunt hard enough, the dimensions are absolutely there. The other thing that's really handy in real life, if you have this printed out, as soon as you use a dimension, take a Sharpie and scribble it out, because you now know that dimension is done. It's already in the design. You don't need to use it again. A lot of people will accidentally double up dimensions, and if you need to type in the same dimension twice, you screwed up, because it means it already exists. You could have used it as a reference. So it is all of those microscopic little tests really do add up. So let's get started on this. I'm noticing this is made in kind of a normal isometric orientation. So I'm going to start off with a right plane extrusion. So let's go into, I'm going to open up Fusion. Let's make a new sketch on the right-hand plane. And I'm just going to be making this rough sketch. Again, no dimensions are necessary so far, just for the sketch. That seems fine. I'm noticing this is 14 and 14, and then an angled face. And then the width and height of this would be recorded as 28 millimeters for the width and 28 millimeters for the height. Fantastic. Oops. And so I can tell you right from the beginning, those two lines are going to be equal. And so are these two lines, which means that this angled is going to be a 45 millimeters. So this is 28, and that means this is 14. That should fully define it. Yes, it has. So then I want to finish the sketch. I'm going to go ahead and extrude this as well. 50 millimeters. Let's go 50. Fantastic. The other thing that's really important is that if you design things cleverly, this isn't symmetric in any way, or all of the any stages of its complexity aren't mirrorable. But if you design it cleverly about the origin or symmetrically about a plane, then it means you don't need to make an offset plane to mirror something about, because your front plane or any of the original 3 planes are already there. So knowing the orientation or the location of your model before you actually get into it is absolutely critical. Okay, so this is 50. So this is going to give me essentially this very, very blocky rando shape, but that looks okay. The next thing I'm going to do is essentially make a sketch on this top plane that is going to be cutting downwards. So I'm going to go back, and it's going to be this kind of weird rectangular shape that has cut off. Kind of a cubed off corner right there. There we go. So this is 2 enclosed profiles. That's perfectly fine. Then I can see it's got 7 and 7 and 14. Grand. So the distance between that's 7 mil. That means that this is 7 mil tall. Whoops. 7 mil. There we go. And then the distance from there to that projected point that I got is 14 millimeters. Then I just need to worry about this section, which I believe was 7. Yes, it was. Fantastic. All right, lovely. So it means this sketch is all done. So then I can extrude these two profiles downwards. How far is it going down? Well, it's going to leave me with 7 millimeters on the bottom. Oops. And so I'm going to say, well, I don't remember how tall it is, for example. So I can say the extent, the final distance is going to be the underside, and I'm going to offset that minus 7 millimeters. That'll give me a bottom floor of 7 millimeters tall. And then the last thing is the circle. So this is going to be 14 millimeters from that edge, 14 millimeters from the bottom. And is it saying the diameter? No, we'll figure that out later. So that's going to make a new sketch. Oh, actually, this is a really good point. Well, so I know that I have the whole tool, but I don't have a location of where this is. So I could make a sketch on this top surface and then use the whole tool to snap onto that point and then just call it a day. But in the exact same amount of steps, I would need to make a sketch on that surface for that center of that circle and then extrude it through. So both ways take the exact same amount of time. So where did it say it was? 14 and 14, 14. Okay. So let's make a new sketch on that surface. Make a circle. This is going to be 14 from the bottom. And then 14 from that edge as well. And then what did we say for the diameter? That was the one value that wasn't defined. So let's check this out. So it looks like, okay. So here is the trick. So this or this hidden line right here, as you can see on here, these vertical lines.
Which hidden line?
On the front, the front view, these two.
Are you looking at Fusion or the drawing?
The drawing. Can you not see my screen?
Oh yeah. Okay, I can see the drawing. Yeah. Yep.
Yeah.
Go ahead.
These two vertical lines right here. These are denoting the left and right edges of this circle. If we go to the right view, you can see that this vertical line represents the right edge from that view, and this left edge is also sharing the same hidden line as this cutout right there. So it means that I need to make this edge of the circle tangent with that line right there. If I extend
when you
this
say
line
this
out,
and that, the thing we can't see is your mouse.
Oh, really? Oh, that's annoying.
Yeah. So there is no mouse on screen on the website. Yeah.
Oh,
so
that's annoying.
I can see. Oh, can you move your mouse now? Yeah, I can't see your mouse at all. Well, we'll try to figure that one out. I think you have to share the whole screen. But yeah, I don't know. Well, I can see the drawing, but I can't see your mouse moving on that drawing at all.
That's annoying.
So we're going to work these bugs out each week.
Yeah. Essentially, the left edge of the circle in the right view is tangent to the little extrusion on the inside of the isometric view. So if I go back into here and say, yep, it's tangent, this is tangent to that edge right there, that fully defines it. And then I can just extrude that circle through all, so to all, and oh, it's already cut it. There we go. So I've made this in 6 steps. So if you guys want to go ahead and remake this in real life using any other methods, see if you can beat 6 steps. This is the most basic approach to that project. If I really kind of hunker down, I might be able to get it down to 5. But that's a pretty small amount of steps. But this is a challenge for the week.
Yeah, there may be. So there is a couple of other competing ways to think about this, Jake. I just want to point out briefly. So one way, as you're making these, is to think about efficiency in the actual process of CAD. And that's certainly viable in most instances. But there is another way to go about it. And this can help if you're actually trying to manufacture it. And that is if you're not actually interested in the ultimate efficiency, but rather you're trying to think through the process of how you might make it, you may approach this differently. And one example is that Dan says, well, how are you going to make those corners on the inside? So the process of you going through making this design in CAD may be just that, a process for you to figure out how to make it in real life. So you may, if you're going to try to make it in sheet metal, not design it the same way as if you were going to try to make it out of wood, as if you're going to try to 3D print it. So 3D printing it, you might think additively, you might be concerned with Are there overhangs? Are there places in this drawing where the printer's likely to fail? And also with other making / machining technology. So I guess my point here, many ways to think about doing this. Efficiency is one of them, and it certainly is useful inside of a CAD environment. But if that's not your goal, be clear about what your goal is with doing this stuff. If your goal is to make it in real life and to kind of think through that process as you go, you may design it slightly differently, and that's okay too.
Definitely. All right, guys, that is going to call it for this week. Really quick reminder, thank you very much, everyone who has gotten a book on Amazon. We unbelievably appreciate it.
Thank you.
If you would please leave a review,
if you could take a photo of the book in your hand on a cool project, extra bonus points. Amazon then, I guess, bumps these reviews up and they get reviewed a lot quicker. So any photo of the book will do, but it's especially cool if you can do it on a fun project or, show something that you've made associated with the book. We would be super doubly extra grateful. Thank you all so much. This has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we will see you next week.
See you guys.